Okay, very good morning, students. In the previous class, I was explaining about foundation, definition for foundation, and then different components or structural components in building, and difference between shallow foundation and deep foundation. So these are the topics. These are the topics we have discussed already. But in this present slide, I want to explain you about different types of shallow foundation, and this is a very important topic. So I want to brief about shallow foundation and deep foundation. Based on the width and depth of foundation, we are going to decide this is shallow and deep foundation. Shallow foundation, as we already defined, the less, that means the width of foundation is larger than the depth of foundation, then that will be shallow. If depth of the foundation is very large compared to width of the foundation, then it will be deep foundation. So we have many classifications under shallow foundation. So those are categorized like this: spread footing, second one is combined footing, third one is mat or raft foundation, fourth one is grillage foundation, fifth one is trap footing, sixth one is stepped foundation. First one is a spread footing. The name itself indicating here we are increasing area gradually in order to spread the load or in order to reduce the stress. So these type of footings are used. Usually we will use or will apply spread footing for wall, column, or in other cases. Here if we use for walls, that will be classified as wall footing. If we use spread footing for column, that will be defined as column footing. If it is used under the foundation in inverted arch, then it will be inverted arch footing. So first one is wall footing. So here observe the figure what I am showing here. Here a PCC, that means plain cement concrete, is laid below. So this what you are seeing is a PCC, plain cement concrete, of usually of thickness 100 to 150 mm, nothing but 10 centimeter to 15 centimeter. And you can observe the width. Always width of foundation or width of PCC depends on wall of the footing, wall masonry. So it may be stone masonry, or sometimes we can use brick masonry. So here we have a projection of width 50 mm or 5 centimeter on either side. So this appearance will be of step by step. So these are defined as step footing or spread footing. We are spreading the area gradually. So you can observe both the figures. So here in this case we have given a offset of 15 centimeter on either side. On the left side 15 centimeter, on the right side it is of 15 centimeter. At the higher level it has been decreased to 5 centimeter, and here the depth of that increment is of 10 centimeter or 100 mm. So we will observe the features of these things. You can read out what I explained or I have explained now, that are written in this lines. It is constructed by brick or stone. If we construct by using brick, that is defined as brick masonry. If we construct wall by stone, that will be stone masonry. 50 mm or 5 centimeter outside offset is provided on either side. That means we are giving an offset of 5 centimeter or 50 mm on either side, on the left and on the right. Depth of each course is 100 mm, nothing but. So this height is of 5 centimeter or 10 centimeter, it depends. Here it is written depth of this increment is given as 10 centimeter or 100 mm, and then 75 mm outside offset is provided on either side for stone masonry, and then a PCC layer is applied below the footing of thickness 100 mm or 150 mm. So this thickness of PCC is of about 100 to 150 mm. So this is about spread footing. Next, column footing. If the footing provided for isolated columns, then they are defined as column footing. They are used to support individual columns. So these are used when columns are reloaded and steel reinforcements are provided for that. A concrete bed is laid at the bottom. Based on the shape, these are again categorized into square footing, circular footing, slope footing, and once again square footing with pedestals. So we'll see the figure, and this will help you people to understand better. So you can observe here, in simple footing, based on the shape, these are categorized as square footing. So these three figures showing the square footings. First one is simple footing, second one is sloped footing. So here we are providing slope, that means here it is completely a square, it is here sloped. At the junction of column to the footing, it is sloped. And the third one is stepped footing or spread footing. And here, based on the shape, this is classified as square footing. When size of the column or shape of the column is square, then definitely not necessarily be square, but usually will provide square footing for square columns. If rectangular columns are provided, then rectangular footings are provided. You can observe the shape. So B1 and B2 are not equal. Here B and this, if we call this as A is equal to B. Here these sides are not equal, opposite sides are equal. B2 and B1 are different. In case of circular footing, if circular columns are there, for the circular columns we can provide circular footing. Inverted arch footing. So this is also classified under spread footing. So normally, usually will provide these type of footing in bridges. Here, in order to increase the contact area, or in other words, in order to reduce the pressure, we provide inverted arch footing. It reduces depth of excavation. These are all the advantage of using inverted arch footing. Here, if you want to construct an inverted arch footing, a clear supervision or technical supervision is needed compared to other types of footing. Series of inverted arches will be provided along the rows of piers. Piers are defined as columns in between the abutments. So usually in bridges we see these type of structures. We'll provide a series of inverted arches. In the next figure you can observe very clearly how it will be. So this is an inverted arch footing provided. So what we are seeing, the vertical structure, what we are seeing or observing is of piers at the last ends, at the abutments. We will call the end supports as abutments and in between supports as piers. You can observe that. And It depends on nature of soil and type of load coming on the pier. This inverted arch footing depends on type of soil. So you can observe this inverted arch footing. Here one important advantage of this arch footing is it is increasing the contact area. That means for the particular stress or load, it reduces the pressure. So this is one of the advantage. And one more advantage is we can avoid over excavation. That means we can reduce the excavation cost. So this is important one, combined footing. The name itself indicating we are providing a common footing for two columns, then we call these as combined footing. Name itself indicating combined means we are combining a footing commonly for two columns. That is meaning of combined footing. These may be of rectangular or trapezoidal shape. So in this second figure given at the bottom, the shape is of trapezoidal in nature. One side, that means in the left side you are seeing shorter side, at the right side you are seeing the longer side. So this is of trapezoidal shape. So here advantage is, in order to restrict the width of the footing, we will provide a common footing for two columns. So these combined footings are provided under following conditions: when two columns nearer to each other, when SBC of soil is very less, that means safe bearing capacity of soil is very less. Usually in case of block cotton soil, we provide this type of footing. When the column is located near the property line, in order to restrict footing line over property line. That means when the boundary line is very near to the second column, in order to restrict the footing, in order to restrict the line of footing, we will combine a footing for, that means commonly for two columns. To have same intensity or same pressure, we will give trapezoidal shape for these type of footings. Mat or raft foundation. Name itself indicating mat means just like a, by increasing the area and reducing the thickness of foundation or footing, so these type of foundations can be laid. So here we will lay the foundation over large area. It consists of slabs and beams. So here in this type of foundations, two types of beams are casted. One will be main beam and second will be secondary beam. So you can observe in the figure very clearly, by using reinforcements we will lay the mat over large area by including all the columns, by providing a primary beams and secondary beams, main beam running along the longer span, secondary beam connecting main beams over shorter span. So these increases the load bearing capacity and it reduces the pressure intensity, and it is suitable for public buildings, schools, offices, etc. So this is one of the important advantage of mat foundation or raft foundation, to reduce the intensity of pressure and to have higher load carrying capacity. So this is the figure in examination. If they ask explain about RAFT foundation or mat foundation, then you have to explain this mat foundation with a schematic diagram what we have written here. So these are some of the advantages of providing mat or RAFT foundation. It is suitable for soft soil, and in other words we can say cohesive type of soil and marshy lands, that is watery soil. Overall settlement can be reduced because the total mat acts as a single unit. It doesn't allow for differential settlement. Load distribution is uniform and it carries more load compared to other types of footing. So this is another type of foundation in shallow foundation, grillage foundation. It is applicable when the load of the structure is very heavy and safe bearing capacity of soil is very poor. Here in grillage foundation we introduce steel structures or steel stanchions like I section or C section. Combinedly we will cast steel stanchions and with concrete. Normally it is used for steel stanchions or columns. It consists of steel sections, rolled mild steel joists. I sections are interconnected by a spacer bar. These can be visualized with this figure. So this is a schematic diagram which is showing the grillage foundation. Here you can observe, so this I section or these are defined as beams provided adjacent to each other. So this is a cross section you are seeing, and this is the plan. So you can observe here, so these are some of the beams provided, and these are the connectors connected. So these are the steel sections, and these are the secondary beams provided along y direction. This I section or column, I section column, and these are some of the angles provided. In the cross section you can observe, so this is a column rested on the I sections. These are some of the I sections provided adjacent to each other and connected to the main beam. So this is one of the important foundation, and here you can see color photography of this grillage foundation. These made of concrete. So this is second type, and these are the grillages provided, and this is the base plate, and these are the angles, and this vertical member is I section, that is column. By studying all these type of different types of shallow foundation, here we can have a clear idea to differentiate between different types of foundations. Basically now in this slide I want to differentiate between two types of foundation, that is, one is mat foundation, second one is grillage foundation. Usually mat foundations are casted over large area. No columns are erected over mat foundation. In grillage foundation it is provided for single steel columns. A second difference is it is used when isolated column is not suitable. In grillage foundation It is used in factory or workshop sheds. So by seeing those differences, you can observe or you can easily memorize what is mat foundation and grillage foundation. Next one is strap footing. So here strap means a beam connected between two footings constructed separately for two columns adjacent to each other. In strap footing, two or more footings are connected together by a strap beam. It is provided when the soil is soft and subjected to heavy load. The strap beam doesn't transfer any load, but it connects two columns which is adjacent to each other. That means it avoids differential settlement. So you can see in this figure, you can observe very clearly that strap is a beam connected between two footings that are constructed for two columns which are adjacent to each other. Main aim of constructing this type of strap beam is not to avoid differential settlement, and it holds the two footings constructed adjacent to each other. Stepped foundation. Name itself indicating stepped foundations are provided in hilly areas where the ground slope is very steep. In order to avoid deep excavations, the structures or foundations are made like a stepped in order to provide basements for wall masonry or stone masonry. Timber or steel piles are driven to avoid slippage of the building. The plinth beam is provided or constructed above the highest footing. So this is about different types of shallow foundation. In examination, they will ask any one type of shallow foundation. You have to define with a schematic diagram, and you have to write advantages and disadvantages. Now, after knowing different types of shallow foundation, now we could able to calculate the width and depth of shallow foundation. In order to calculate width of wall foundation, we have two criteria. One will be based on load and SBC of soil, and second one is by knowing the thickness of wall and extension or offset provided along both ends. First criteria you can observe by calculating total load per meter length acting on the structure and allowable SPC of soil, which is already calculated by using load truss method or plate load test. So here in total load it includes dead load, imposed load or live load, wind load and snow load. Sometimes we will consider seismic loads. By considering all types of loads divided by allowable safe bearing capacity of soil, that means F divided by W divided or F, we can call it as force or load, F divided by sigma, nothing but area of the foundation. per meter length, if you want to calculate per meter length, then it will be converted into width of wall foundation. In the second formula, if you want to calculate width of foundation, 2 times of thickness of wall plus 2 times of extension or offset. By comparing these two values 1 and 2, we can select greater value, so that will be width of footing. So now at this stage I will wind up the class. So next we will study how to calculate depth of foundation by using Rankine's formula. Thank you.